Over the last decade, the adoption and availability of planter technologies have increased across farms in the southeastern United States, providing growers the ability to precisely place seed in areas of the field that they desire. Furthermore, benefits of using planter technologies appear to have some benefit in other crops commonly grown in rotation with cotton, such as corn and soybean. Planter technologies that allow growers to switch varieties on the go are commercially available to those who wish to use it. With all new technologies, it is essential that growers understand how to properly use them, implement them into current production practices, and maximize profit or return on investment with them. Up to this point in time, the majority of growers who have adopted these technologies are utilizing it to simply switch corn hybrids in and out of irrigation boundaries. If these technologies are purchased for one commodity, such as corn, and have merit in others, such as cotton, soybean, peanut, the technology's cost could be distributed among several enterprises. Preliminary research conducted at Clemson University began in 2019 to evaluate multi-variety planting with nematode-resistant and nematode-susceptible cotton varieties. Aside from host plant resistance, there could be several other opportunities for cotton producers to plant multiple varieties depending on factors such as irrigated versus non-irrigated, historical areas of the field with excessive growth, and soil texture variability. To fully understand the benefit of multi-variety planting in cotton, further research needs to be conducted. A research project funded by the South Carolina Cotton Board was initiated in 2020 with three main objectives. First, to determine the benefit of planting multiple cotton varieties in the same field. Second, to determine how this would affect growth and development, lint yield, and overall profit in cotton production. Finally, to evaluate prescription development methods with regard to multi-variety planting. One field at the Edisto Research and Education Center near Blackville, South Carolina, that is representative of South Carolina coastal plain and typical cotton production practices was used in this study. This research includes 4-row strip plots planted across a field that has variable soil textures. Cotton was planted in early May with a planter equipped with variable rate seeding meters. Soil electrical conductivity, or soil EC data of the field, was collected prior to planting and management zones were created. 6 cotton varieties were selected and planted based on local irrigated and non-irrigated OVT data from the irrigated and non-irrigated Clemson OVT trials at Edisto Rec. Uniform variety strips were planted in and out of irrigation boundaries, as well as all other multi-variety combinations to evaluate the potential benefit of multi-variety planting. Cotton varieties included Delta Pine 1646 and Delta Pine 1835, NextGen 3729, Stoneville 5600, and Phytogen 580. Since varieties were also planted across soil textures within the field, other factors associated with variety selection, such as seed size and rate of emergence, will be evaluated. After harvest this fall, yield data will be collected and evaluated to determine if any specific combination of multi-variety planting provided greater net return compared to uniform variety planting in and out of irrigation boundaries. From this research, we expect to provide recommendations on multi-variety planting in cotton in terms of profitability and using local OVT data to drive variety selection. This research fits into the Edisto Rec mission by connecting fundamental agronomic practices of cotton production with precision agriculture technologies like multi-variety planting capabilities on planters to better place cotton varieties in environments where maximum yield and profit potential can be observed. This research is important to cotton growers in South Carolina because it will demonstrate whether or not multi-variety planting in cotton has any profit potential.